So Deepseek everyone have been shaking things up, both in the AI space and on Wall Street for days now. I know I'm pretty much late to the party, but it's been really fun to watch all the closed source AI companies freak out about an open source model. But first of all, let's talk about its specs. Now, Deepseek everyone comes in at around 671 billion parameters, and it has a context length of 128K. And something that's not talked about enough is its size when comparing it to these closed source models. Like over here in this chart, they did compare DeepSeek R1 to OpenAI O1 and O1 Mini. This I think is previous version of O1, but still O1 nonetheless. And we do not know the parameter size of OpenAI O1 family of models. But we do know that GPT-4 was 1.76 trillion parameters in size, and its predecessors were much smaller than that. So we can safely assume that the OpenAI O1 family of models would at least be 1.76 trillion parameters. And the reason why I'm actually stating this is because if we are actually comparing it to a 671 billion parameter model, I think DeepSeek R1 is really, really doing well because it's is definitely crushing O1 Mini. It's definitely crushing it, and it measures up to OpenAI O1, even though this was a previous version that was released on December 17th, 2024. But it's still O1 nonetheless, and it's honestly really, really cool to actually see. Even though I do not actually trust benchmarks, I do not take them seriously. I prefer to use the models, and then depending on my use case, I would actually see if it performs really well. I do not trust benchmarks, but I do love this benchmark. Like, I love this chart. It's a very, very beautiful chart, honestly, because it's just cool to see an open source model crushing a closed source model. Like, it's really beautiful to see. That's just it. And even the distilled version, that is the 32 billion parameter distilled model, is really doing well. Like, it's measuring up to O1 Mini, even though it's just a distillation, it's not the real model. So that's really cool to see, honestly. That's really, really cool to see. Now, let's talk about something more serious. Let's talk about how they achieved this state of the art model. Now, first of all, what they actually did was they had a base model, and if we go over to Jargon Face page, we can find DeepSeek V3 over here and DeepSeek V3 base. And you can also view the paper, the technical report. So DeepSeek V3 is a mixture of expert model. It's same size as R1, but it's not a reasoning model. That's just it. So let's go back to R1. And what they actually did was they applied reinforcement learning to the base model, which I just showed you, DeepSeek V3, without supervised fine-tuning preliminary step. They didn't actually apply SFT to the base model, which allowed the model to explore chain of thought for solving complex problems. And this gave birth to DeepSeek R10, this model over here. Now, this was the model that came before DeepSeek R1. DeepSeek R10 is the first open research project to demonstrate that reasoning capabilities of LLMs can be incentivized purely through reinforcement learning without the need for supervised fine-tuning. That, like, it's just cool to actually see. If you actually go over the paper, you scroll to the aha moment. Let's look at the aha moment. See, a particularly intriguing phenomenon observed during the training of DeepSeek R10 is the occurrence of an aha moment. This moment, as illustrated in table 3, occurs in an intermediate version of the model. During this phase, DeepSeek R10 learns to allocate more thinking time to a problem by re-evaluating its initial approach. This approach is not only a testament to the model's growing reasoning abilities, but also a captivating example of how reinforcement learning can lead to unexpected and sophisticated outcomes. Now, it's really cool because it was not fine-tuned to actually do that. It's just emerged on its own, like it emerged autonomously. Like, that was just the cool part. Now let's go back to DeepSeek R1. Now, there was a problem with DeepSeek R10, and the problem they ran into was that even though DeepSeek R10 demonstrated capabilities like self-verification, reflection, generating long COTs and all that, it faced issues like endless repetition, poor readability, and I think that was due to its mixed language use because it kept mixing English and Chinese when actually outputting text. So to fix these problems and to improve DeepSeek R10 reasoning abilities, DeepSeek R1 was born. And unlike DeepSeek R10, DeepSeek R1 incorporates cold start data before reinforcement learning. Now, the cold start data are just basically initial examples given to the AI to help it start learning. Like, that's basically it. And if we go over to the paper again, we can scroll to the cold start section. You can see, unlike DeepSeek R10, to prevent the early unstable cold start phase of reinforcement learning training from the base model, for DeepSeek R1, we construct and collect a small amount of long COT data to fine-tune the model as the initial reinforcement learning actor. To collect such data, we have explored several approaches using few-shot prompting with a long COT as an example, directly prompting models to generate detailed answers with reflection and verification, gathering DeepSeek R10 outputs in a readable format and refining the results through post-processing by human annotators. Now, these are some of the options they actually explored, or some of the approaches they actually explored to actually add cold start. So it's just really, really cool to see. So enough for the test by moonlight. Let's try DeepSeek R1, and we're going to put it to the test with 6 questions. These are the questions we actually gave Marco O1. I think that was the first attempt at open source reasoning model, and we are going to give the same question to DeepSeek R1, and we are going to play with the questions a little bit because we are going to be using the main DeepSeek R1 model. We'll have to go over to DeepSeek AI, their main website, to actually use the main model. And then at the end of the day, we are going to also try out the distilled models. We're going to try the small distilled models that I can actually run on my PC, and I will show you how to get it set up on LM Studio and also Ulama. So let's dive in. Let's go over to DeepSeek AI. You can go to chat.deepseek.com directly. So I'm already logged in, and one of the questions I actually asked it was this. And a small ball is put into a normal cup, and the cup is placed upside down on the table. Someone then takes the cup and puts it inside the microwave. Where is the ball now? So you already know the answer to this question. It's really simple if you're a human being and you've interacted with objects. Basically, the ball is supposed to be on the table naturally, except it rolled down. But anyways, it got the answer right. It said the ball is on the table where the cup was originally placed. Here's the reasoning. Initial setup: when the ball is placed inside the cup and the cup is inverted, opening face down on the table, the ball rests against the table surface, held there by gravity, which is really cool. The cup's rim blocks the ball from rolling away. Nice. Lifting the cup: when the cup is lifted to be moved into the microwave, the ball is no longer confined by the cup's rim pressing against it. Since there's no force like suction or adhesion keeping the ball attached to the cup, gravity causes the ball to stay on the table as the cup is lifted away. The result: the cup is placed into the microwave empty and the ball remains on the table where the cup was initially positioned. This outcome assumes normal conditions, no vacuum seal, rapid movement, or other external forces. Nice, like it's just got it right. The ball is on the table where the cup was originally placed. That was the answer it gave us, which is really cool. So I'm going to delete this particular chart because it actually has memory and of chart history. And I'm going to ask you the question again. But if you look over here in 2024, I think this was the V3 when they were actually using DeepThink, the normal DeepThink. It actually failed it. It said since the cup is upside down, the ball stays inside due to gravity acting downward. He said the ball is inside the microwave, still inside the cup. This was one of the questions I actually asked it. When V3 came out and the DeepThink was actually enabled, so it actually failed, even though it was using DeepThink. That was in 2024. I think maybe that was DeepSeek R10. I do not know. It's either V3 or 0, but I actually used DeepThink. So that was just it. So instead of all this, what I'm going to do now is really simple. I'm going to delete this. Now I'm going to create a new chart and I'm going to ask it that same question. So I'm going to ask it 6 questions, and these are the questions I'm going to ask it. 1, how many are in strawberry? But I'm also going to play around with the strawberry. I'm going to spell it wrong and to see if it can follow instruction and also if it will spell it correctly. So just in case they actually beat the word strawberry into it and beat that particular answer into it, so we will know if it actually really reasons. Now, the next question is how many words are in your response to this particular message? That's another one. Then the third one is since this particular question I previously asked it, which I just deleted right now, a small ball is put in a normal cup and the cup is placed upside down on the table. Someone then takes the cup and puts it inside the microwave. Where is the ball now? So in these questions I'm talking about, I'm not going to be telling you to think it step by step or whatever. Since it's a reasoning model, it's meant to do that by default. And since they actually had the breakthrough in Deepseek R10 where reasoning became an emergent behavior, it's meant to actually do that. So the fourth question is: John has 10 apples, he gives away 4 and then receives 5 more. How many apples does he have? This one is really simple. Then the fifth question is: which is a faster way to get to work? Option 1, take a 1000 minutes bus, then a half hour train, and finally a 10 minutes bike ride. Option 2, take an 800-minute bus, then an hour train, and finally a 30 minutes bike ride. Then the last one is: write me a snake game in Python. Now that should be really simple since this is a very large model. And as you can see, Deepseek R1 is enabled here. So the moment I actually do this, I can then paste in the questions I want to actually ask it. So let's dive in. So now for the first question, let's ask it how many R are in strawberry. But I'm going to remove the A and add an extra R. So it's going to be 4 R's. So you'll see if it can actually reason like I said earlier. So let's perfect. It said 4 hours. That's a perfect answer. Really cool. Because if you look up here, say the user is asking how many R appears to be in the word strawberry, blah 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 blah. Then the correct spelling, so it can actually follow instruction, which is really cool. Because after that, it ignored it and say let's write out the word as given. Simple. That's really cool. So as for our second question, we're gonna ask it this: how many words are in your response to this particular message? And like I said, make sure Deepseek R1 is actually selected. This question is actually driving it crazy. There are 10 words in my response to this message. It failed it in the worst possible way because it was actually done thinking here. This is its output, and it kept giving step by step explanation, which it did not count at the end of the day. And then it said final answer. Now, even the final answer, even if you say, okay, let's take the final answer and count it, it's not up to 10 words, as you can see. And then it does the verification and then puts this here. And this is not what is even in the final answer. It's a fail, and that's too bad. So for our next question, I'm going to ask it this particular question. We've asked it before. Let's see if it's going to get it again. The ball remains on the table. That's cool. That's really good. Step-by-step explanation. Initial setup. The ball is placed inside the normal cup, which is then inverted on the table. Gravity holds the ball against the table surface inside the cup. Lifting the cup. When the cup is lifted vertically, the ball typically remains on the table due to gravity and lack of addition or suction. So since it actually got this, what I'm going to do is start a new chat and I'm going to ask it the same question, but this time I'm going to change this to mug. Okay, so there's no cup in this particular sentence. Now let's so it's actually correct. The ball is on the table where the mug was initially placed upside down. The small ball is placed inside a normal coffee mug, which is then turned upside down and set on the table. When the mug is inverted, gravity will typically cause the ball to fall out unless it's somewhat trapped. However, since the mug is placed upside down on the table surface blocks the mug's opening, temporarily keeping the ball inside. When the mug is lifted to be moved into the microwave, the table no longer blocks the opening. Without a lid or suction to hold it, the ball will fall out due to gravity and remain on the table where the mug was originally placed. The mug itself is now in the microwave, but the ball stays behind. Cool, really cool. It actually did a lot of thinking on this one. Okay, that's good. That's really good. So as for our fourth question, we're gonna ask it. John has 10 apples, he gives away 4 and then receives 5 more. How many apples does he have? It's too simple. So that's good. It actually got this one correct. So this is our fifth question. Which is a faster way to get to work? Option 1, take a 1000 minutes bus, then a half-hour train, and finally a 10-minute bike ride. Option 2, take an 800-minute bus, then an hour train, and finally a 30-minute bike ride. So it actually got it correct. That's really good. And so for the final question, we're going to ask it to write a snake game in Python. This should be really easy since this is a reasoning model and it's a really large model. So let's see what it actually outputs. We're going to see if you can actually get it in one go. So it's actually done outputting this, and that's good. It actually is Pygame. Now we're going to copy this code and we're going to create a Python file and we're going to run it. I already have my virtual environment set up, so I'm not going to do any of that in this video. So this is the code it actually provided. There are no errors, as you can see over here. Now let's run it. It's moving really fast. Nice, it's actually growing. I'm a terrible snake player. I'm actually really terrible at this. Nice. Space to restart. It actually restarts. The score increases. Really good. Really, really good. Nice. That's really good. So that's a pass, which is expected as a reasoning model, and since it's actually this large, this is really good. Now let's switch over to the distilled models and let's talk about the distillation and how they actually pulled it off. Now, regarding distillation, which they actually use to empower small models with reasoning capability, they actually said to equip more efficient smaller models with reasoning capabilities like Deepseek R1. They made a typo here. We directly fine-tuned open source models like Quen and Llama using the 800K samples curated with Deepseek R1 as detailed in 2.3.3, which is up here, where they talked about rejection sampling and supervised fine-tuning and how they actually curated the reasoning data and the non-reasoning data. But for the reasoning data, they said we curate reasoning prompts and generate reasoning trajectories by performing rejection sampling from the checkpoints from the above reinforcement learning training. In the previous stage, we only included data that could be evaluated using rule-based rewards. However, in this stage, we expand the data set by incorporating additional data, some of which use a generative reward model by feeding the ground truth and model predictions into Deepseek V3 for judgment. Additionally, because the model output is sometimes chaotic and difficult to read, we filtered out chain of thought with mixed languages, long paragraphs, and code blocks. For each prompt, we sample multiple responses and retain only the correct ones. In total, we collect about 600K reasoning related training samples, and they talked about the non-reasoning data here for writing and factual Q&A. So as you can see over here, these are the models that they actually distilled. Now, the base model we use here are Quen 2.5 Math 1.5b and Quen 2.5 Math 7b, Quen 2.5 14b, Quen 2.5 32b, and Llama 3.1 8b. Okay, just another Llama 3.3 70b instruct, which is which is really amazing. So they use two math models from Quen and then a normal base model, the 14 billion parameter model. They use the base model, and also the 32 billion parameter model from Quen was actually the base model. And they used Llama 3.1. I wonder why they didn't use 3.2. Anyways, we select 3.3 because its reasoning capability is slightly better than that of 3.1. Why didn't they use 3.2? I do not know why. But for distilled models, we apply only supervised fine-tuning and do not include an reinforcement learning stage, even though incorporating reinforcement learning could substantially boost model performance. Our primary goal here is to demonstrate the effectiveness of distillation technique, leaving the exploration of reinforcement learning stage to the broader research community, which is really cool of them. So to set up Deepseek R1 locally, I think it's more efficient to actually use the quantized version. If you want to use it on your PC, it's best to actually do that, and it's best to actually go for one of the distilled models, except you have the beefy GPU or you have a server farm or something that you want to run the main model from. You can just get the model weight here and quantize it yourself, or you can actually go over to Llama and make sure you've downloaded it. It's available for Mac OS, Linux, Windows. Those are the three operating systems. So go over to models and you're going to see Deepseek R1 at the top because it's just trending. Honestly, it's just trending. But if it's no longer here, maybe it has been dethroned, you can just search for it using this search bar and you can click on it. And by default, the 7 billion parameter model is the one that's actually selected. So once you copy this and go over to your terminal and paste it, so the Olama run Deepseek-R1, all it's doing is loading up Deepseek R1, but they have a check. It actually checks if that particular model has been downloaded. If it hasn't been downloaded, it will automatically download it for you. If it has been downloaded, it will just load it up. So, but if you just want to pull the model and maybe run it later, you can do Ollama pull Deepseek-R1. So it's really that simple. But I do not need the 7 billion parameter model on my machine. I have the GGUF quantized version. I do not need this on Ollama. So I'm going to be canceling that. The one I actually have on Ollama is, if I go over to Ollama list, I have the 1.5 billion parameter model. So now we're done with all that. What I'm going to be doing is using the Deepseek R1 1.5 billion parameter model to power up a reasoning tool. And that tool is going to be connected up to an agent, a structure chart agent. And this agent is going to be powered up by a different LLM entirely. I'm not going to be using the Deepseek R1 for the model to power that particular agent. And the reason is, if we go over to their paper, as you can see here, they actually stated it here. In the future, we plan to invest in research across the following directions for Deepseek R1. General capability. Currently, the capabilities of Deepseek R1 fall short of Deepseek V3 in tasks such as function calling, multi-turn, complex role-playing, and JSON output. And that's really, really true. Because when I actually tried using one of the distilled models for to power an agent, it failed a lot of times. Like, it failed to generate the proper JSON output. Sometimes it's actually really slow because of it's actually reasoning and all that, and it's just kind of messy. So that's something I need to actually improve upon, and I think in the next situation they would actually do that. So enough ranting, let's just dive into the code. So we have system of Pi open, and the central logic for this particular AI system can be found here. I covered this particular AI system in a previous video where I was actually introducing the concept basically. So this particular AI system uses a task manager to handle some of the tools, and you can specify the tools you want to be handled with the task manager. So you can actually keep interacting with the AI assistant even though there's a reasoning task or an analysis task running in the background, and the AI assistant can be notified when they are actually complete. But for this particular video, we are going to only use the brainstorm tool, and we have that here, as you can see. So let's open it. Okay, we have our argument schema over here. As you can see, brainstorm input, and it's a single input. And since it's a single input, it's not that necessary. But since I'll be making lots of other changes to this particular tool, I left it that way because I'm going to be updating it really, really soon. Since this is going to be my personal assistant, I'm going to make this tool way more robust than this, and there are lots of other stuff I'm going to be adding, like a GUI and all that. Well, anyways, let's just run it. But first, FYI, this AI system currently uses Whisper and Note embedding model for voice identification and transcription. Just letting you know so you don't ask in the comments. Anyway, and also it uses the recently released Kokoro TTS as the text-to-speech model. So what we're going to be doing is we're going to run it, and we're going to ask the AI system to brainstorm about the multiverse. So it will definitely use the brainstorm tool, because if you go over to this here, as you can see, we have brainstorm tool here. Now, if we go over here, as you can see in our inputs, we gave it a description, the user inputs to be processed. And in the tool description, we gave it use tool to brainstorm or think about complex problems used for solving difficult tasks. Anyways, hello, how are you?
Hello, I'm Genesis, your AI companion. I'm doing great, thanks for asking.
Could you brainstorm about the multiverse?
The concept of the multiverse is a profound and multifaceted idea that intersects both physics and philosophy, offering significant implications for our understanding of existence and reality. It challenges traditional notions of identity and reality, leading to debates on realism versus idealism. The multiverse posits the existence of multiple distinct realities coexisting simultaneously, each with unique physical laws and interactions. This concept extends beyond quantum mechanics to encompass any theory with potential multiple outcomes or configurations. While it remains a theoretical construct, its implications for both fields continue to spark deep discussions on how we understand the universe.
How are you doing today?
Doing great, thanks for checking. How's your day going?
Goodbye, Genesis.
Farewell, I hope our brainstorming session was as productive as it was entertaining. Let's catch up on another adventure soon.
So, we are actually done with that. So as you can see, that's this basically is a very simple concept. Just for those that want to actually integrate this into their AI system. So for my final thoughts, Deepseek RO1 represents a very significant step forward in AI reasoning capabilities, especially in the open source space. And it's really cool to see an open source model crush one of the closest models, especially one that comes from OpenAI. It has been wonderful to watch the meltdown. Anyways, its performance across various benchmarks. The chart I actually showed earlier, that chart actually shows the benchmarks that are basically the industry standard tests for AI. It shows that reinforcement learning can be effectively used to create more capable AI models, and that's just really cool. And it's also really, really cool that they actually released their research paper to the open source community, like it's open weights and open source. That's very wonderful. So people can actually replicate it. So it's just net positive all around. But anyways, I can't wait for their next iteration, for the next model that comes after this. Maybe that one would actually perform better at function calling and can be used for agentic systems. So that's going to be it for this video, and thank you for watching. Make sure you do like, subscribe, share, and hit that bell icon if you want to be notified when I actually release a new video on this channel. And since we're on our way to our first 1000 subscribers, I do urge you to subscribe. Do not forget, hit the subscribe button, and do not be greedy, just like the video. Just like the video. Thank you for watching. Have a nice one.